Light transmitted by Nicol prism is. Options are given. A Nicol prism always gives plane polarized light. That means direction of vibration of light is only in a single plane. So option A is the correct one. Plane polarized light is passed through a Polaroid. When the Polaroid is given one complete rotation about the direction of light, one of the following is observed. Options are given. Consider this is a Polaroid and this allows light which are vibrating in this plane. So we are going to rotate the Polaroid. When the Polaroid becomes 90-degree, the vibrations cannot pass through the plane. So the intensity becomes 0. Now, again, if you rotate, it will come in the same plane so that it will give maximum intensity. Again, if you rotate, it will become again perpendicular and you will get minimum intensity. Then again, if you rotate, it will come in this direction so that maximum intensity you will get. So you are getting twice maxima and twice minima. That means option D is the correct one. Intensity of light is twice maximum and twice 0. Ratio of intensities of two coherent waves is 4:1. Then the amplitudes of the two waves in the same order. We know that intensity proportional to amplitude squared. Or we can write I1 by I2, that is proportional to A1 by A2 whole square, or A1 by A2 is equal to I1 by I2 whole raised to 1 by 2. That means square root of I1 by I2 is 4:1. So you will get 2 by 1, or option A is the correct. The correct graph showing the relation between fringe width beta and the distance between the slits small d for a fixed screen distance capital D and given wavelength lambda is. We know that beta, fringe width beta equal to lambda d divided by d, or we can write beta proportional to 1 by d. As d increases, beta decreases, or vice versa. In all these ABCD graph, C is the correct one. As beta increases, D value decreases. So C is the correct option and we call it as rectangular parabolic. So correct option is C. In Young's double slit experiment, the separation between the slits is halved and the separation between the screen and slit is double. The new fringe width, if the original is beta, is, we know that fringe width beta is equal to lambda d divided by d. Here it is said that separation between the screen and slits doubled. So d becomes 2d and slit separation is halved, that is d by 2. That means 2 will go to the numerator. So you will get lambda 2d into 2 divided by d. Or you can write 4 lambda d by d. And this means 4 times lambda d by d is beta. So the new fringe width will become 4 times beta. Option D is the correct one. Unpolarized light of intensity I0 falls on Nicol prism. The light emerging from the Nicol prism falls on another Nicol whose polarizing axis is inclined to that of the first by theta degree. The light emerging from that second Nicol has intensity. Consider a ray of light of intensity I0 falls on first Nicol. Let this is the vibration of light in this plane. Then the emerging light falls on another nickel, which is at an angle 30 degree with the first. Then the emerging light intensity I we can write I equal to I0 by 2 cos square theta, that is I0 by 2 cos square 30, that is I0 by 2 cos 30 is root 3 by 2 whole square, that is I0 by 2 into 3 by 4 or 3 by 8 I0. So option D is the correct one. On introducing a thin mica sheet of thickness 2 into 10 raised to minus 6 meter and refractive index 1.5 in the path of one of the waves, central bright maxima shifts by n fringes. If the wavelength of the wave is 5000 Armstrong, then n is. Equation for shift is n lambda equal to mu minus 1 into t. We should find out n, that is mu minus 1 into t divided by lambda, where mu is the refractive index and it is given by 1.5 minus 1 into t is the thickness, that is 2 into 10 raised to minus 6 divided by lambda is 5000 angstrom, that is 5000 into 10 raised to minus 10. When you calculate this, you will get 2. So option B is the correct one. A ray of unpolarized light traveling in air is incident on a material of refractive index root 3 at a polarizing angle. Then the angle of refraction inside glass is. Let a ray of light incident on a material of refractive index root 3. Then it gets reflected. Then a part is refracted also. Let this is the normal. Then this we call angle of incidence. This is angle of reflection. And this one is the angle of refraction. So Brewster's law states that the angle of incidence for which the reflected ray becomes completely polarized is called Brewster's angle. So when this reflected ray becomes completely polarized, we can call this angle of incidence as Brewster's angle. We know that angle of incidence is equal to angle of reflection. So we can write this also as IP. And also at Brewster's angle, the angle between reflection and refraction, that is reflected ray and refracted ray, becomes 90 degree. So let us consider all these things and find out the value. By Brewster's law, we can write mu equal to tan IP, that is mu is given root 3, that is tan IP, or Brewster's angle we can write tan inverse root 3, that is 60 degree. And also from this we can understand that IP plus angle of refraction R is equal to 90 degree. Therefore R is equal to 90 minus IP. So 90 minus 60, that is 30 degree. So refracted angle is 30 degree. The first diffraction minima due to single rectangular slit diffraction is at theta equal to 30 degree for a radiation of wavelength 500 Armstrong. The width of the slit is. For a diffraction minima, we can write n lambda equal to A sine theta, where A is the width of the slit, or we can write A equal to n lambda divided by sine theta.
N is 1 because it is for the first minima. Lambda is 500 Armstrong, that is 500 into 10 raised to minus 10 divided by sine 30. Then we can write 500 into 10 raised to minus 10 divided by sine 30 is 1 by 2. This 2 will go to the numerator. When you calculate this, you will get 10 raised to minus 7 meter or 10 raised to minus 7 into 100 centimeter. That is 10 raised to minus 5 centimeter. So option B is the correct one.
At what angle should an unpolarized beam be incident on a crystal of refractive index 4 by 3 so that the reflected beam is completely polarized? By Brewster's law, we can write refractive index mu equal to tan IP, where IP is the Brewster's angle. That means angle incidence for which the reflected light is completely polarized. That is called polarizing angle. So we can write 4 by 3 is equal to tan IP or IP equal to tan inverse 4 by 3, that is tan inverse 1.33. So let us compare the tan value. So it will come between 45 and 60 degree because it is greater than 1. So the angle will come between 45 and 60. That is option C, 53 degree.